All right, let's get started. Good afternoon and welcome, and thank you for choosing to spend your next hour with me. Now, do you live in fear that your continuous delivery pipeline is going to break your production environment? Because if you are, then you're not alone. This is a talk about adding safety to your deployment process. And I'm not talking about adding extra unit tests or extra integration tests. I'm talking about configuring your deployment process so it's safer and configuring your release pipeline so it can react to bad changes. Hello, my name is Mark Mansour, and I own the teams that build continuous delivery tools at Amazon. So we're going to make our production pipeline safer by adding more monitoring to our production environment so that we can identify issues quickly. We're going to configure our deployment engine so that it adds more safety checks. And we're going to modify our pipeline so that we are proactively detecting changes in our environment. All right, so we're going to look at 5 techniques today. So the first technique is we're going to continuously test production to see if we have regressions in functionality. Our second technique will be configuring our deployment engine so we're testing our deployments after each host update. We'll also look at segmenting production so it's not one big glob. And we'll halt promotions to production when our system is under distress. And we'll finish up by creating gates in our deployment process which will open and close due to external stimulus. So a key component of being successful at continuous delivery is having all of your processes automated. So this would mean that you already have your code in some sort of version control system, you've automated your builds and your deployment process, and you're probably deploying to more than one host at a time. You have unit tests and integration tests, which you have confidence in will catch regressions. And you've got this all tied together in some sort of automated fashion with a continuous delivery tool. You will also have an operations dashboard, which will give you real-time visibility into the health of your production system. With all of those things in place, you'll end up with a pipeline that looks something like this. You'll end up having some source, which will trigger an automated build where you'll run unit tests and maybe some style checks. You'll then promote that build into an integration environment, run integration tests against it, and if that's successful, you'll then go on to production. Now, from a 10,000-foot view, this is a talk about best practices. And the best practices I'm going to go through should be usable with any of the tools that you have today. It may mean that you have to extend your tools, but that's just part of building a continuous delivery pipeline. Now, to make these techniques more concrete, I'm going to be using AWS tools to show you how to build these techniques. Now, there are a lot of AWS tools, so I'm not going to assume that you know them all. So let's just step through the 3 categories of tools we'll be using today. So we'll be using monitoring tools, software development tools, and deployment tools. We're going to use monitoring tools to capture metrics and to raise alarms when there are issues going on in production. We're going to use Amazon CloudWatch as our metrics and alarming provider. We're going to use software development tools to extend the behavior of our continuous delivery process. We're going to use SNS to emit events from our pipeline, and we're going to use Lambda functions to change the behavior of our pipeline. And we're going to use deployment tools to get bits to boxes. AWS CodeDeploy is a deployment engine that deploys code to EC2 instances. AWS Code Pipeline is a hosted pipeline tool that orchestrates your release management. So here's, again, our abstract release process, and we're going to move it into Code Pipeline just so we can make this a little more concrete. Now, you'll notice that each of these abstract steps map neatly into Code Pipeline's actions. And let's just go through some concepts. From top to bottom, this is a pipeline. This models our release process. Within a pipeline, we have stages, where stages collect one or many actions together. Now, an action or a plugin will act on every change that runs through our system. And this is where the real work happens in our systems. So we've got several different types of actions. We've got source actions, which might react to a GitHub commit or a code commit. We've got deployment actions, which may perform a deployment through CodeDeploy, which we'll be using, Elastic Beanstalk, CloudFormation. And we also have approval actions, which can wait for external stimulus, whether that be a manual approval or whether that be an approval via an API. Now, between each of our stages, we have transitions, and transitions can be enabled or disabled. When we disable a transition, any change running through our pipeline will pause at that disabled transition, and when it's re-enabled, the code will then continue to flow through the system. When somebody commits a change to your source location, again, this triggers a change to run through your pipeline all the way through each action, and then at the end, it's very likely that you'll deploy to your production environment. So we're going to use our pipeline to deploy to CodeDeploy, and on the left-hand side of the screen will be our release process. In the center of the screen, I'll be showing you our deployment process. So here, our pipeline is triggering a deployment to CodeDeploy, and CodeDeploy is going to deploy to 3 hosts. By default, it will deploy to 1 host at a time in a rolling fashion. Now, we're going to come back to this slide throughout the talk and incrementally build up both our deployment process and our release process to make this much more robust. So now that we've got the prerequisites out of the way, we can actually get it onto our techniques. But first, a story. Now, we all run some pretty complicated systems, and they can break in some fairly unexpected ways. And I remember working with one team that had a buy button disappear from their site. And it disappeared because they had a dependency on another system that was sending them inventory data. And when the data was returned, it was missing the data that was required in order to render the button. Now, the team didn't know that this problem was occurring, and customers had to call them up and let them know that there was a problem. And this caused quite a bit of frustration for the customers. They were surprised that the team didn't know about the problem. But once they found out, they could obviously fix the issue. Now, in an ideal world, you as a service team would find this issue quickly and resolve it. So I think the lesson to take away from this story is that although your system is working well at one point in time, it can degrade at a later point in time. And you need some telemetry to understand when this occurs. So to solve this problem, we can create synthetic traffic tests that will simulate real customer behavior to identify problems before customers see them. Now, these synthetic traffic tests should be testing all of our business-critical functionality. And if we were a retailer, for instance, we might want to check a login, an authentication. We might want to check adding items to a cart, and we may want to check the checkout process. We want these tests to run quickly. If we have a 20-minute test, then that's a 20-minute latency before we find out that the system is broken. So we want really our tests to run every minute, and so we can react and get on top of that problem. Now, we get some extra benefits because we behave like the customer. We can also see customer information such as latencies and whether the site has remained reachable or not. So when a customer interacts with our site, the normal thing happens. They make a request, they get a response back, and our server will also send a message back to our monitoring system to tell us whether that request worked or not. Our synthetic tests will work exactly the same way. They'll send requests into our service, a response will come back, and the service itself will push some data to our monitoring system. In addition, though, our synthetic tests will also push whether the test passed or failed back to our CloudWatch metric stream. We can invoke these tests every minute, and we're going to be doing that with CloudWatch events. And if we have a deployment that has a problem, and we have a regression in our business-critical functionality, then we can send that message back to CloudWatch and alarms can fire. Now, it might be a little bit confusing why we have 2 metric streams being emitted. So if you go back to our previous example where the buy button disappeared, customers interacting with that website will continue to have a normal experience, and there'll be no 500s being thrown from your server. It won't error out. So we won't receive any errors coming back from the service to just our standard monitoring system. But our synthetic tests are actually performing business-critical functionality tests, so we'll be able to pass or fail that result and send it back to our monitoring system on which we can alarm on. So let's build one of these tests. It's pretty easy to do. Now, I'm going to do a simplified version of these tests. I'm going to not create a login or create adding items to a cart. For the purposes of simplicity, I'm just going to grab a web page and check that there is text on that web page. I'm going to be building this with Lambda, and I'm going to be sending my monitoring information to CloudWatch. So Lambda has blueprints which allow you to quickly generate applications. And Lambda already has a synthetic traffic test built into it. So it's called the Lambda Canary, and there's a little secret. At Amazon, we call synthetic tests Canary tests. So that's why the Lambda team has named it the Lambda Canary. As part of setting up this test, we also can create this scheduling system that occurs through CloudWatch events. So here's the code that gets generated. This is almost line for line exactly what gets generated. So I've replaced the site with a URL that I own, and I've pasted some text that I want to search for. And then we have the URL open method, which grabs the web page, and the validate function, which will tell me whether that text is on the page. Now, if the text isn't on the page, we're going to raise an exception. And that exception tells Lambda that we failed the action. And every call that you make to Lambda automatically gets logged to CloudWatch. So now we know in CloudWatch that there's an error that the text was not on our page. If everything works well, we'll simply return some data. We'll just return the time in this case. Now, Lambda functions, as I said, automatically report the health back to CloudWatch. So here are some Lambda functions that I own and the metrics that they report back. So they report back things like duration and how many invocations have occurred, whether we're throttled, and whether there are any errors. We can then quickly turn those into a dashboard. You can see on the top, I've got the invocations. I'm calling 1 a minute. And on the bottom line, I'm showing errors. Now, what I would do here is I'd create 2 alarms. I'd create one alarm that would send me an alert when I receive an error back from my Lambda function, because it means my business-critical functionality has regressed. I would also create a second alarm that would fire when I have a lack of data. So if I did not receive metrics for 3 consecutive data points, I'd have an alarm run, because at that point in time, I know my canaries are not working. My synthetic tests are not working. So the process to release and deploy changes isn't really altered by this particular technique, but it does give us critical information on the health of the system, and this is a building block we need for the further techniques. So let's move on to managing our deployment's health. Now, I remember one of our teams had built a new internal service, and they were getting ready to launch. And as part of our regular launch process, we perform an operational readiness review. And during this readiness review, we look at the dashboards that the team has built, and we happen to look at the availability metrics for this team. Now, it turned out that the week earlier, they'd had a total loss of availability for a short period of time. So we dug in and found out what was going on, and it turned out that they'd created a new table, and they'd misconfigured the table name, done a deployment, and it had stopped their service from standing up. It's fine, they weren't live. They fixed the change, pushed it back out, and everything was great. But the engineers missed an opportunity. They missed an opportunity to harden their deployment service because they were 100% down during that time. So let's have a look at how we can modify your release system so you don't end up in this same situation. Now, we're using CodeDeploy as our deployment engine, and CodeDeploy performs rolling updates to our EC2 instances. Now, this slide shows a rolling update occur. We take a host out of the load balancer, we update the code, we then place it back into the load balancer so it can serve traffic. Fairly straightforward. But rolling deployments by themselves do not verify that an application actually works. Which means if you're the group that I was talking about before and you add a change that breaks your service, you are going to roll out to production and update each host, and then none of them are going to work, but they're all going to be reattached to the load balancer, which means that your customers are not going to see the results that they want. So by default, deployment systems are totally agnostic to your application. They know how to get bits to boxes, which means, unfortunately, that they don't know that your service is running. Now, rolling deployments need 3 checks to make them safe. We need to check, after we've done a deployment on a host, that it's stood up correctly and it can serve traffic. We need to ensure that when we're doing a fleet deployment, that the minimum number of hosts are working. And if they're not working and we fail our deployment, we want to roll back to the previous version. So let's look at how to set this up. Now, CodeDeploy can be configured to run scripts at different parts of the deployment lifecycle. It has an AppSpec.yml file which defines those lifecycle events and the scripts which we're going to run. Now, the last lifecycle hook is the validate service hook. And at this point, we're going to check that our service is stood up, that we can fire a result into the top of the service and get a good result back out. And once that is done, and only once that is done, we're going to add it back into the load balancer. So let's assume that we've now done this and we perform another rolling update. We're going to continue to do our deployments until we hit a host that does not work correctly, and at that point, we're going to halt the deployment. So that's great. We now have a situation where bad hosts are not put back into the load balancer. But it leaves us with 2 other problems. Excuse me. It leaves us with the issue where one host failing stops us from getting out to the rest of the fleet. So imagine if we had 100 hosts and one host fails. We actually don't want to stop the deployment at that stage. We want to quarantine that host and continue to roll out to the rest of the fleet. The other issue that we have is half of our fleet is on the old code base and half of our fleet's on the new code base, and we've got one of our hosts which is out of service. So let's look at the next 2 steps on how we can fix these issues. So CodeDeploy has a concept of minimum healthy hosts, and this defines the minimum percentage of hosts that are healthy in order to continue a deployment. So let's use an example. Let's say that we've got 10 hosts and we're going to set the minimum healthy host rate to 70%. If we now did a deployment and one host failed, then we'd have 90% of our hosts healthy and we would succeed this deployment. Alternatively, if we deployed to our fleet and 6 out of 10 of our hosts worked, that would mean that only 60% of our minimum healthy hosts exist and we would fail the deployment. So that's great. That gives us a little bit of flexibility on deploying out to production. We can configure this in CodeDeploy. So CodeDeploy comes with a default setting of deploying to one host at a time and failing if that host fails. It also comes with defaults of deploying 100% at a time, which you might use in your integration environment, or 50% at a time. Now, if these configuration settings don't work for you, you can define your own with the CLI. Now, at Amazon, we define a minimum healthy host percentage to be at least 66%. And we only want it to be 66% or more because if we have a bad deployment, we still want 2/3 of our fleet available so we've got capacity to serve our customer traffic. So this is a fairly safe setting. But using validation tests and the minimum healthy host setting get us a long way. They stop a lot of problems from reaching into production with hosts that are unable to start. But then we need to clean our fleet up, and this is where rollbacks can help us out. So if we fail our deployment, we can configure CodeDeploy to automatically roll back when we breach those settings. So now we've modified our deployment process in the middle so that we run tests after each host has been updated. We now look to see if we've breached our minimum healthy host settings, and if we have, we'll perform a rollback. This also leaves our release management unchanged. Excuse me. So let's talk about segmenting production. So I remember a team that, as part of their regular release process, ended up breaking the add items to a cart functionality on their site. Now, they'd already implemented synthetic traffic tests, so they identified this problem very quickly and were able to revert to a healthier deployment. But customers were calling in furious because this was a very high traffic site and customers needed to get their job done. Purchasing was part of their job and they just couldn't. And unfortunately, when you deploy to all of production at once and a bad change gets out, it affects all of your customers. So if you leave production as one big pool, then the risk of a bad change affecting all customers is just too high. The blast radius is too big. So we're going to reduce the risk of affecting all customers by segmenting production into pieces. Now, once we've segmented into multiple pieces, we're going to deploy to a segment, we're going to run tests on that segment, and then we're going to continue to deploy and test until we've got code out to all segments in production. So, as I said, step one is to break production into multiple segments, and segments, you can think of a segment as a blast radius. The smaller the segment, the smaller the blast radius. The most obvious segment type is by region. And AWS has the concept of a region, which is a collection of data centers that are geographically close together. And we tend to deploy to one region at a time so that a bad change in one region never affects a bad change in another region. Quite a lot of our services also like to deploy at an availability zone at a time, where an availability zone is a collection of data centers that are logically close together. And having a zonal deployment strategy ties your code changes to a network topology, so this can be quite useful too. Now, some of our very large teams don't deploy to a zone at a time, they deploy to a subzonal region we call a cell. But you need to be at quite large scale to want to go to a cellular style architecture. But one thing all teams want to do is they want to do just a little test before they go out to the rest of their segments. So this is a Canary deployment where they deploy to a single host, make sure it's working correctly before then deploying out to the rest of production. So your release process really is a reflection of the level of safety that you want to achieve. The minimum configuration I see is a Canary deployment followed by a regional deployment. But a more typical scenario I see is a Canary deployment followed by a 3AZ deployment with 3 hosts in each AZ. Now this is a lot more servers, and so in order to reduce cost, we move to cheaper instance types, smaller instance types. So the process we're going to do is deploy to a Canary, do a Canary deployment, run some validation tests, and then once that's verified, we're going to move on to our next segment, which in this case happens to be an availability zone. If that availability zone is deployed to and works correctly with our post-deployment tests, we'll then start fanning out and deploying to a wider range of hosts. In this case, we'll deploy to the last 2 availability zones at the same time. So as we gain confidence, we broaden our blast radius. So we can model these segments in CodeDeploy. CodeDeploy has the concept of deployment groups, and deployment groups allow you to associate an application with a set of hosts. Now, a deployment group can identify hosts based on their EC2 tag, their auto-scaling tags, or a combination of the two. And this gives us really great control of where exactly our code is going to end up. So we're going to model our Canary deployment as one deployment group, and we're going to model each zone as another deployment group. Now this ends up in our release process looking something like this. We end up having a Canary deployment that goes to a single host, followed by a test, a post-deployment test, to verify that that deployment was good. We then deploy out to an AZ, and we test to see that that AZ has not had a regression in functionality. And then again, we fan out to the remainder of our availability zones. And this works well for a lot of our customers. Now notice we don't do a test at the end of our last validation, at the end of our last deployment. And that's because we're already running synthetic traffic tests which should capture regressions already. So I've spoken a lot about the post-deployment step, the thing that we do after we've done a segment deployment. But now I want to get into the way those tests actually work. So we want to gather enough information after a deployment that we've got confidence that the deployment was good. Now, each call to our service is already logging some metrics back into CloudWatch. It's already logging whether the calls are successful or unsuccessful. And we can use the CloudWatch metric stream as a data source to give us some confidence on whether the deployment is good or not. We can combine that with looking for alarms in production. If there are some sort of service level alarms going off, then we probably want to halt deployments to production as well. And we want to place some sort of timeout around all of this so that tests don't take forever. So we're going to need to build some post-deployment tests and add them into our pipeline. And we could write tests as a test action or a Lambda invoke action or a custom action in CodePipeline. The nice part about using these test types is that they're very easy to write, but they have a limitation, and that is that they can only run for a maximum of 1 hour. And some of our post-deployment tests are going to take a lot longer than 1 hour. So there's another approval type that we have called approval actions, and they'll wait for some sort of external stimulus to occur. And approval actions have a 7-day timeout. So they're going to give us plenty of time for us to run some sort of external check and validate whether our deployments were working or not. So I want to show you the pattern that we can use in order to use approvals as tests. So when a change hits an approval, we can configure an approval to emit an event on an SNS topic. That message can be used to trigger a Lambda function, which we can then use to write our tests. We can perform whatever tests we want at that point. If everything's good or not, we can call back into our pipeline and put an approval result which says either it worked or it didn't work. And once that occurs, if it's approved, changes will continue to flow through to our remaining actions. So here's a screenshot of an approval action being configured. And we can configure this to send a message on an SNS topic by just throwing in the SNS ARN here. We also have a comment field, and a comment field is raised to the approver. Now, if this was a human approver, we'd just write some human readable text, but our approver is going to be a Lambda function. So we're going to pass through machine readable text, we're going to pass through a JSON blob. And in that JSON blob, we're going to pass through configuration that's required for this test. Now, in this case, we want to pass through the metric stream, how many data points we want to collect to feel confident that the deployment is working, what alarms we want to check for in production to see whether we're in distress, and whether we've timed out. So let's take a look at the end-to-end flow of what this would actually look like. So as a change rolls through and hits our approval action, it will emit an event on our SNS topic. That message will trigger a Lambda function, and we're going to write that information to our DynamoDB table. That's going to contain all the information about the approval that we want to process. That is the end of that flow. Now, in the background, we're going to have another Lambda function, which we're going to call on a 1-minute basis. We're just going to have a CloudWatch event, call that on a regular basis. It's going to read the DynamoDB table, and it's going to process each of these validations. Now, the validations, as I mentioned, wrong way. The validations I mentioned are going to check the metric stream, they're going to check that we've timed out, and they're going to check whether alarms are fired, and if everything's great, then we're going to call back into the pipeline and approve the test. So we're going to dig into these two Lambda functions. Now, the first function up the top here is our register deployment function. And its goal is really just to take the approval information and shove it in DynamoDB. So here's the method that will push this information into Dynamo. Now, the handler in Dynamo takes an events parameter. And in that events parameter will be all the information from our SNS topic, including the approval information. We're going to pull that out because it's already in JSON, and we're going to store it in a local variable. Now notice I'm doing some not great coding practices here. I'm assuming we've got an array of size 1 and I'm just pulling out an item. This is slideware, so we'll have proper code later on. We're going to write that data out to a DynamoDB table, and we're going to come back and process that in our second method. So here's our second function that we're calling every minute to actually run the tests. So it needs to read a CloudWatch metric stream and make sure we've got enough positive data points to believe we've got confidence in the deployment. It needs to check that alarms are not firing, and we then need to time out. Now, I'm not going to show you all the code for this because it's a little long, but it will be available after the talk in our AWS Labs account on GitHub. But what I will show you is how easy it is to call back to CodePipeline to approve the result. So here's our approval method, and we can call the put approval result function. And we're just pulling all the data back out of our approval message that we popped off the SNS queue and wrote to the table, and that'll have our pipeline name, our stage name, our action name, and whether we're approving or rejecting the message. With that call, everything will continue to work. So I want to briefly talk about Canary deployments though, because they are slightly different from other segments. Firstly though, the way that they're the same is that they participate in serving production traffic. They're configured as a normal production instance, and they contribute to the normal production metric stream. But they also emit a second metric stream. And the reason we do this is we don't want our Canary data to get drowned out with the rest of our production fleet. You can imagine a situation where we have hundreds of hosts and only one Canary, and you're merging those two streams together, then any Canary noise will just get washed out. So in these post-validation tests, these post-deployment tests, we're going to use this Canary's custom metric stream as the data stream to test whether the system is continuing to work or not. So segmenting production provides us with the safety we need to prevent bad changes from impacting all of our customers. And we need to segment production into at least two segments, a Canary deployment and a regional deployment. If you're a larger team, you'll probably segment even further into zones or cells, and then you'll run a test after each deployment to make sure that it works. Now, segmenting our deployments has a really big impact on both our release process and on our deployment configuration. You'll see that we now have a Canary deployment and a regional deployment, and we now have to reflect that in our pipeline. We'll also be adding in a zonal deployment in this example, and that will also be reflected in our pipeline. And then between each of our segments, we need to run post-deployment tests, and those too need to be reflected in our pipeline. All right, let's talk about halting promotions to production. So at AWS, we regularly review incidents that happen on our services. And I remember one of our internal services, an HR system, had a problem where one of their hosts had gone wonky and it was throwing alarm. It was just throwing bad results back. So the engineer, the operator, jumped online and took that host out of service so that he could diagnose the problems with that host. Unfortunately, in the background, their pipeline triggered off a new deployment and brought that host back into service. This was frustrating for our customers because our customers now received bad traffic, which our customers were our internal customers like me. And it's also frustrating for the operator because the operator now has a lot more moving parts going on in production, and it makes it more difficult to diagnose. So when your systems are experiencing some sort of availability event, it's helpful to keep the production system stable. And so we want to disable deployments into production during an availability event. So let's build one. So when your system is suffering this availability event, there should be alarms firing somewhere. Now, you may have service-level alarms that fire when your particular service is not well, or you might have company-wide alarms that fire when some broader issues are happening in your company. Either way, that's a good notification that you want to stop deployments to production. Now, we've already built synthetic tests that will tell us when there is a problem in production. And we can use those alarms to call another Lambda function to disable promotions to production. Once we've resolved our issue in production, we can then manually re-enable that transition and allow changes to flow back out to production again. So the code to disable a code pipeline transition is quite trivial. Code pipeline has an API named disable stage transitions. And we can call that with the pipeline name and the stage name, and whether we're going to disable the inbound or the outbound transition. We can also provide a reason for disabling the transition as well. This is what it looks like in the UI. You can see that the transition has been colored out. And when you click on it, you will see the reason for the transition to be disabled. And again, you just click the enable button and changes will then continue to flow through to production. So let's wrap up halting promotions to production. Basically, if there's an issue going on in production, it's worthwhile stopping promotions. We want to give the operator time to diagnose issues in production. And to do that, we just disable our stage transitions. All right. So our release process has now been updated to disable promotions into production. And we're starting to build a release process that is sensitive to environmental concerns. So let's talk about some gates. Now, in many businesses, there are key dates throughout the year when they cannot afford to have anything go wrong with their production system. If you're a sporting site, then it's important that your site remains stable through a big event like the Super Bowl. If you're a retailer, it's important that your site remains stable during Black Friday. At Amazon, these sensitive deployment times of the year are called Black Days. Now, during these sensitive times, the risk to return ratio for performing a deployment change isn't very favourable. A bad production change during a sensitive time may not only affect the reputation of your business, but it might also affect your bottom line. So deployments to production should be a regular and normal occurrence, and I hope they are for you. But during these sensitive times, the business should be able to halt deployments in order to make production safe and stable. We can think of these black days as gates. Gates that open and close as we enter and exit these sensitive days throughout the year. And to have this enforced company-wide, we actually need every pipeline to have a common action inserted into its release process. In Code Pipeline, we can create black days using approval actions and have a Lambda function to approve that action when it's not a sensitive time. So let's go have a look at this. So let's use an approval action to build a system that halts deployments. And so when a change rolls through and we have an approval, a black day approval, we can fire off a message on an SNS topic. We can have that call a Lambda function, and we can write that data to a DynamoDB table. So we'll have our black day information in that, the current date in that DynamoDB table. We'll then have a Lambda function that runs in the background that polls that DynamoDB table, and if we're not in a sensitive day, we can approve the pipeline approval. Now, this should all look familiar to you all because this is our black day architecture, and this is the architecture that we have for post-deployment tests. And they're effectively identical. The logic in the two Lambda functions is slightly different, but they really are there to achieve the same purpose. The first Lambda function's purpose is to write the approval information into some persistent store, and our other Lambda function's job is to perform the test that's required in order to either approve or reject the approval action. So, approval actions are a flexible tool for building a variety of tests, including gates. Now, in this technique, we used company-wide black days as an example of a centralized policy. And centralized policies can be managed in pipelines. And to do this, we add common actions into every pipeline. Black days can be thought of as gates that open and close when our pipeline is allowed to deploy to production and close during sensitive times. And in code pipeline, gates can be implemented as approval actions. Now, to add even more safety to our release process, we can now pause deployments in production when we have a heightened sensitivity. So that finishes my review of the 5 techniques to improve your deployment process. And my goal here was to teach you a few techniques to make your pipeline safer. Now, I hope these techniques not only make your customers happier, but they make your on-call operators happier too. And this wasn't just a talk about handling a bad change once it reaches production. It's also about modifying your release process and your tools to behave in a way that works for your team. So to recap, we can use continuous production testing to react quickly when there are problems with our production environment. We can deploy safely to production by setting up our deployment configuration to test after each host update and to roll back when a deployment fails. We also learned that we could segment production in order to reduce the blast radius to our customers. And we wrapped up with a technique to manage our pipelines. So we could automatically halt deployments when production is in distress. And we learned that pipelines can be customized to change the flow of changes to production according to external gates. Now, we've dramatically overhauled both our deployment processes and our release processes. We now have real-time data on the health of our system coming from synthetic traffic tests. From a deployment perspective, we've added 3 new tests that didn't exist before we started. We're testing that each host can serve traffic. We're testing that each segment deployed to does not cause a functional regression. And we're testing whether when a deployment fails, that we cause a rollback. From a release perspective, we've also added in the ability to halt promotions to production when the system's under distress, and we've provided a centralized gate so that your company can have more control over your deployment processes. I really hope that you've learned something new today, and I hope that you can apply some of these techniques to your continuous delivery process. Thank you very much.